and today I am going to teach you types of instructions and instruction set supported by 8085 microprocessor. In this session, we will cover the following topics. First, introduction of instruction and instruction set. Second, types of instruction according to size, means 1 byte instruction, 2 byte instruction and 3 byte instruction. And then we will learn types of instructions according to operation. Whenever a user wants to perform some task, he or she will give instruction or program, means group of instructions to the computer system. So, when user gives instruction to the system, it is first stored in the main memory and then for execution purpose, it is transferred to CPU. So here we need to understand what is instruction. An instruction is a command to the microprocessor to perform a given task on specified data. As you all know, each instruction has two parts. First, opcode and second, operand. First, opcode means operation code. It is an operation to be performed on data. And the second is the data to be operated on all the operand. For example, here we will consider this instruction move a comma b. In this instruction, move is opcode, means operation to be performed, and that is a data transfer operation that we are going to learn in this session. A and B are registers in which operands are stored. The operand or data can be specified in various ways. Data can be stored in computer registers or computer memory. In some instructions, the operand can be given as immediate input. It may include 8-bit or 16-bit data. And what about instruction set? The entire group of instructions that a microprocessor supports is called instruction set. And 8085 has total 256 instructions. Each instruction is represented by an 8-bit binary value. The 8085 instruction set is classified into 3 categories by considering the length of the instructions. The length is measured in terms of byte rather than word because 8085 microprocessor has 8-bit data bus. 3 types of instruction according to word size are first byte instruction, second byte instruction and third byte instruction. Format of 1 byte instruction is given here. In this type of instruction, the opcode and the operand of an instruction are represented in 1 byte. Operands are internal registers and are in the instruction in form of codes. Why this is? Let's say example of. For example, if I am writing instruction move C, A. In this instruction, 1 byte is occupied for opcode move and operand are specified using the internal registers. Registers are internal component of microprocessor so that they do not require any memory location. Similarly, in the second instruction, that is CMA, means complement accumulator. The accumulator is assumed to be implicit operand. These instructions are in 8-bit binary format in memory and each requires 1 memory location. In short, if there is no numeral present in the instruction, then that instruction will be of 1 byte. Next, format of 2 byte instruction is given here. In a 2 byte instruction, the first byte indicates the operation code and the second byte indicates the operand. For example, if I write this instruction MVI A,32x, and this instruction, the first byte will be for the opcode MVI and the second byte will be for the numeral 32x, that is 8-bit data value. In short, if an 8-bit numeral is present in the instruction, then that instruction will be of 2 bytes. Here, the numeral may be a data or an address. And last, format for 3 byte instruction is given here. In this type of instruction, the first byte indicates the opcode and the following 2 bytes specify the 16-bit address or hex. In this instruction, the first byte will be for the OP code LDE, means load, and 2 byte will be for the numeral 2050 hex, which is 16-bit address. In short, if a 16-bit numeral is present in the instruction, then that instruction will be of 3 bits. Here, the numeral may be a data or of address. For example, in LXI, D, 3050 hex, 3050 is a 16-bit data. Now, we will learn instruction set. All the instructions of 8085 microprocessor are classified into 5 categories. First, data transfer instructions. Second, arithmetic instructions. Third, logical instructions. Fourth, branch. And last, control instructions. These instructions are of Intel Corporation. They cannot be used by other microprocessor manufacturers. The programmer can write a program in assembly language using these instructions. First, we will understand data transfer instructions. These instructions are used to copy the data from source to destination or one place to another. While copying, the contents of source are not modified. These instructions move data between register to register and between register to memory. To explain that, basically we have 6 different instructions which is there in 8085. So let's see them. In first category, we have move RD, RS. This instruction copies the contents of source register means RS to destination register means RD. Let's take one example so it will be more clear. Like if I execute move A, B instruction and register B has data 20 hex. So after execution, A has 20 hex means data of B register will be transferred to B register. Second instruction, that is move M, R. This instruction copies the contents of register R to memory. Now here, basic thing we need to understand, memory that is being pointed by HL peg. Here H is equals to 20 hex and L is equals to 54 hex, means memory address will be 2054 hex and data on this location will be loaded by register R. Vice versa transformation of data is also possible, means data can be transferred from memory to register using move R, M, where memory location is pointed by also HL peg. Third instruction, that is MVI R, data of 8. In this instruction, immediate 8-bit data will be transferred to register R. If I execute MVI D, 30 hex, so after execution D will become 30 hex. Next, fourth category instruction, that is LXI register pair, data of 16-bit. This instruction transfers 16-bit data or address to the register pair. For example, if I might write LXI H, 3045 hex, means 3045 hex address will be transferred to H register pair. Now, fifth category instruction, that is LDA, address of 16-bit. This instruction transfers content of defined memory location in the accumulator. If I execute LDA 3091 hex, then contents of memory location 3091 hex is copied into the accumulator. For example, data of 3091 hex location is 67 hex. So after execution of this instruction, accumulator has 67 hex data. And last instruction, that is STA, address of 16. In this instruction, content of the accumulator is stored into memory location. For example, if I write ST3145X instruction and accumulator equals to 55X, then after execution 3145X location has data 55X. That's all for today's session. We will learn other types of instructions in our next video. Here are some questions for you. First, define OP code and operand. Second, give example of 1 byte instruction. Third, explain 2 byte instruction. Fourth, give example of 3 byte instruction. Fifth, list out types of instruction according to operation. And last, list out data transfer instructions. Thank you for watching this video. Please like, share and subscribe our channel for watching more videos.